This is AP Calculus Unit 8 Pretest Solutions. So here we go. Number 1. We have a water tank and we have a positive rate and a negative rate. So positive rate and a negative rate. Okay, so this is a message from John to all of us, including people watching the video. Always make everything into one rate. Never think of them as two separate rates. Always think of it as positive rate, subtract negative rate. If it gives you 2, turn it into 1. It gives you 1, it's still 1. That was the same process over and over and over again. So immediately I would plug this one in my calculator, this one in my calculator, and then do this one minus this one and graph the subtraction. Okay, so let's talk about part A. Is the amount of water increasing at time equals 15? So the most common error, I think almost every single person did this, is they took an integral because they saw amount of water. You're correct in seeing amount of water. I need to somehow go backwards, but it's not asking for an amount of water. It's asking if that amount of water is increasing. So if it's the amount of water increasing, I'm really looking at the derivative. Is the derivative positive or negative? Is the slope going up or down? It gives us the slope already. So what we need to do is we need to look at the positive rate minus the negative rate when we plug in 15. So all you're doing for part A is you're looking at the slope by doing W of 15 subtract R of 15. Again, the reason that I'm not using an integral, even though it's asking for an amount of water, it's asking if that amount of water is increasing. That's the derivative. We're looking at the derivative here at time equals 15.
And you just see if it's positive or negative, basically?
And just see if it's positive or negative. And this one was negative. So I want to show how to do this work on the calculator too, so let me pull that up. So this is how I would run through the problem. So y equals, so my window is going to be from 0 to 18, I'll remember that. So it's going to be 95 square root of t. That's not square root, come on. Square root of t times sine of t divided by 6, all that squared. This one is going to be 275 sine of t divided by 3 squared. And then this one, immediately I'm going to ungraph these two. I'm going to say, I don't want to care about him. I don't care about him. I need them in my calculator maybe for another problem where I have to evaluate it, like in this one. This one is going to be vars right, enter 1. This one is going to be subtract vars right, enter 2. And then I would graph that one. My window is from 0 to 8. Oh, shoot. Second on. I need my window to be from 0 to 18. And then zoom 0.
Oh, so 0 to 18?
0 to 18 because it says that in our problem right here.
I forgot how to do this. I could not remember how to.
Oh, Mr. Sinnell, you know what I struggled with?
What was that?
CVs. I couldn't find my CVs. I'll show you when we get to it.
Okay.
I was being so stupid.
So this is your reason. So you'd say it is decreasing. So your answer should say no. First of all, it's not increasing. It's decreasing. And your reason is because of this thing. So here's our graph. We don't need it right now. What we're really doing is we're plugging in vars right, enter 1. We're doing 15. So in parentheses 15. And we're doing minus vars right, enter 2, y2 of 15. And you'll see that when you do that, you get a negative number. This is negative 121.090. That is less than 0.
We already have the y. So now we have to. You know how I did y1 minus y2 as my y3?
Yeah.
So then how do I use that?
So you ungraph these by hovering over the equal sign and hitting enter so that they're not black.
But so if they're not black, can I still do the
Exactly. Yeah. It won't graph it, but you can still use it.
Okay.
Yeah. Good question.
So what you just did there is the same thing as tracing 15 on the calculator?
That is now, yeah, that's now tracing 15 on the calculator.
And what if I did both, Mr. Snow?
If you did both, what do you mean?
I plugged it in as that, and I got a negative 121. But then I also did trace 15.
So yeah, both of them should get the same answer.
Okay.
Either way, you're going to say that This difference here is less than 0. All right, so for part B, it's asking to the nearest whole number how many gallons are in the water. This is going to be start plus change is equal to end. And for only one time, the time here is 18. So our start, and this is the most common error, people forgot the start. Start is 1,200, 1,200. And then the change is the integral between 0 and 18. Then the reason that we know we're doing this method of start plus change is because it's asking for a number of gallons. So we need to go backwards with our initial condition. So the change is going to be the integral of Wt minus Rt. Wt minus R of t, all of that times dt. And that will equal whatever our answer is. So now I plug this in on our calculator. So I get out of here and I say 1,200 plus math 9 of, and I don't have to say Wt minus Rt, I can just, that is function y, or y3 on my calculator already. Because in here, y3 is y1 minus y2, so I really just have to say vars right, enter 3. y3 with respect to x from 0 to 18. We're in the middle of recording though. Is it a question that I can answer about the pretest? What's your question?
Well, wait, what? So I think, isn't it just smart? Is it about the pretest stuff the whole time? Like, you know that like t, because I never know when to add the 1,200.
So it's, no, I don't think that's a good idea, just because on your graph, if it's ever asking for just a rate, then your rate is messed up by the fact that you have that 1,200 in there.
Okay, so then how do I know when I need to add it?
You need to add it whenever you're doing the total number. Whenever you see the word total, or it doesn't say total in this one, does it? Just how many gallons. I know that this is asking for total. It's interpretation.
Okay.
You just have to think about it like
It's about
At
the self.
tiny
It's about a
T
self
equals
check.
there
Which one?
which one was 1,000?
Yeah, like I need to. Okay. It was just
And that's me too.
Can she send an email, because we are going to run out of time.
Email or something because he's in the middle of a pretest. That's gonna take a while. Keep going, Mr. Snow. No, you're good. Alright, bye.
All right, so you get 1,309.
The nearest whole number.
Hold on, I just want to show the work, and then from there, then we can go to 1,310. So your final answer is 1310, and then don't forget your units, gallons. Yeah.
Wait, just a really fast thing about part A. The only thing you need is W of 15 minus R of 15 is less than 0.
That is the reasoning, but you also have to answer the question. Is it increasing? The answer is no.
No, decreasing because your rate is negative.
Exactly.
Okay.
Perfect. On to part C. So, at what time between that interval is the amount of water the absolute minimum? So, that means we're making a table. So, our table, what is going on here? Come on. Our table here for times t, we know we're going to have 0 and 18 probably for our critical values, our endpoints. We're also going to do start plus change to get our end. All right, so we need to find what points to plug in for t as well. So when I come back to my graph, I notice that there's 2 intersection points. But notice that I don't really need, well, let's see here. I'm looking for absolute minimum here. So that means that I'm really looking for where I just have a negative rate. So I should be looking at this time, but not this time. Why not the second time? You could do it, and then you'll find that you don't need it. But why am I smart in thinking that I don't need to check this time, this 0 right here?
I'm not really sure. That's what I don't understand. Like how you do these shortcuts. And
If you don't know the shortcut, do it the long way.
I
that's
just do
what
it.
I
I just
do.
do it the long way.
So the reason that I'm not doing this point is because I have this giant positive area. Positive area means I'm adding water in here. I can't have a minimum if I'm just adding water. The minimum will be after I take out water. So the minimum will happen at this time, or this time.
Mr. Snow, but that's when I was really confused on how to find that number.
So then you do second, trace, and I'm looking for a 0, 2. And then the left bound, I'm going to look for this point right here. So I'm going to do left point 1, right point, I'm going to guess about 10. And some point, like even 9, even if it's really far off, as long as it's in between, it knows what it's looking for. And it's going to say that 0 is t equals 6.495. 6.495. If you included this 0 as well, I forget what it was, but that's fine. You don't need it because this was a bunch of positive area.
Well, I got that, but I did like second intersect, and then I did all
That's
these
that's
That's what I did as well.
so if you did intersection, that's because you're graphing both y1 and y2. If you only graph y3, it's the same procedure over and over. Just look for the zeros. That's why John made that comment.
Okay. Yeah, because that's how I found them, is like the intersection.
Yeah, enjoy it. The comment that John made is always make this into one function and graph that one function. Don't graph two functions because then it's a little bit different. Same function over and over.
Watch these videos?
He doesn't watch the videos to my knowledge, but we do talk almost on a weekly basis.
Like, do you talk about what we're doing? Like,
Yes.
You talk about us?
You talk
Yes.
about Riley?
No, a little bit.
Wait, what do you say about us? Like,
That you're doing really amazing.
oh, stop.
Okay, the initial condition is 1,200. The funny thing is that you considered your initial point for C, but not for B, for most people. All right, so our change is going to be integral from 0 to 0. I'm not going to worry about it here because it's going to be 0. Our end value for this time of 0 is 1,200. So this is going to be the integral between 0 and 6.495 of Wt minus Rt, and then all of that dt. And to do that on the calculator, I'm going to do it not with the graph because it goes a little bit faster to find 18. I can do second enter. So I'm going to go 1,200 plus math 9 of my vars right, enter 3, my y3 with respect to x from 0 to, and I can just do 6.495. I don't need to save this in my calculator. It'll get about the right answer.
Why are you talking like
I am a robot.
It's because my words don't come fast enough for my body. I know what I want to say. So this is going to be 525.242. And then I do second enter. And then I can find, where am I looking for? I'm looking for between 0 and 18. So this number turns into 18. And get rid of all this. Delete, delete, delete. And hit enter. Cool. I'll fill in this while it's calculating 0 to 18 of Wt minus R of t. All of that is with respect to dt. And come on, what are we getting? I think it's 1,309. Yep, 1,309.7878. Come on, 788. All right, so, and to finally answer what is looking for at what time t. So at time 6.495, it is the minimum. So you say t equals 6.495 and like box that, and you'll get full points. It doesn't even ask for what is the minimum. It just asks for the time. So that's all you really need. Although if you want to put time,
I always say it.
if you do time and amount, you'll always get full points. Yeah, that's a good way to make sure you get the full points. And I guess if you want to be really specific, this is the unit hours. All right, for part D, this was extra credit. This was out of 0 points. So I don't really care about it too much, but I'm going to quickly state what's happening here. It will be on the test, but it'll also be extra credit.
Okay.
So to solve this one, we're looking for when it becomes empty. So what we need to do is we need to say, we don't have any more positive, we don't have any more Wt, we only have an Rt. And we need to basically say, when is this thing going to run out? So I know that I had 1,310 roughly at time equals 18, because it's starting at 18. So I basically need to say 1,800, and I need to subtract some integral of Rt dt. And that integral, I need to use k in it somehow. So I'm starting from 18, so start from 18 to k. And that needs to equal what?
0.
0, yeah.
Oh.
Another way of saying this is you just say, you add the integral of this to both sides, so 1,800 equals integral between 18 and k of Rt dt.
I like your zero.
Wait, how did you get 1,800?
1,800 is,
The start.
I don't know how I got that either.
Shouldn't it be 13?
It should be 1310. Yeah, that's an extra credit point. Sorry about that.
Nice, Kim.
Wait, can you like put in my 2 points too that you haven't put? I have them on my papers.
But it didn't go, oh yeah,
I
so
didn't write them on my tracker.
yeah, make sure you have the date and I'll sign it. Just like Sophia, I didn't sign like 4 of hers. She came out to me beginning of class and I signed them off. All right, so that was out of 2 points. You got 1 point for the bounds, 1 point for the equation. All right, let's move on to the second problem.
Wait, and the reason it's 1,310 is that's because it's the integral from 0 to 18.
Yeah, that is the ending amount that is in the tank at that time, right here. I rounded, of course. It should have been like 1,309.788, but it's fine. They'll give you credit for 1,310 at this point. All right, on to number 2. So this is number 2. The rate at which sewage, so this problem. For sewage, let's go to my notes here.
Same, bro.
All right, so it's asking for entering. It doesn't care about how much is in it, just entering. So we're looking at this equation, and we know that we're looking for gallons, and we're not talking about increasing or decreasing, so we're taking the integral. So it's going to be the integral between 0 and 4. 0 and 4, those are our bounds of our ET function, E, T, dt. And we need to find what that approximately equals to the nearest gallon. So, by the way, a key tip on the AP exam, if you like this, is if you need to come back to this problem, just leave your Y2s, Y3s, and start entering them into Y4s. I know that I'm completely done with the first problem, so I'm going to go ahead and just clear these out. I don't need them anymore.
That's so smart.
Yeah, pro
It's
tips.
like if you have to go back, it's going to take so much time to re-enter a problem.
Exactly, yep. All right, so my ET function, let's enter that. 850 plus, or not plus, sorry. Oh, it is plus 715. 715 times cosine of, it's going to be second to the power of pi t squared, all that divided by 9. All right, so I have my function, and my window is going to be set from 0 to 4. Yep, 0 to 4. 0, enter, 4, enter.
Do we need it?
Zoom, 0. We'll eventually need a graph, maybe. It just helps that while this is working on the side, I can start thinking about how to solve this problem. So 0 to 4, those were the bounds that we were looking at here. And so a constant rate, okay, so this is our positive rate. Oh gosh, I already made a mistake. Do you guys see what I did?
You didn't enter your like positive
Your
or minus.
negative rate.
My negative rate, yeah. So I'm going to come back here to y1, and I'm going to leave y1 because I might need that. And I'm going to go vars right, enter 1, y1 minus 645. It's a constant rate of 645. And I'm going to ungraph this one, and I'm going to zoom 0 again to graph now the combined rates, the positives and the negative rates. All right, I'm only looking for the positive rate here. So once this finished graphing, I'm going to go math 9, and I'm going to go 0 to 4 of my ET function. All right, so here I go. So I'm going to go math 9 of my vars right, enter 1, my first function, my ET, that's going to be with respect to x from 0 to 4. And what do I get here? I think I get about 3,981, 3,981, and to the nearest gallon, so yeah, that's rounded correctly, gallons. Perfect. And that was worth 2 points, 1 if you got the integral correct, 1 if you got the answer correct. For part B, so now it's asking what time is the amount of sewage the greatest. If I'm talking about greatest or least or anything like that, I'm making a table. So my time t, I need my start, I need a plus my end or my change, and that will get me to my end. All right, so what times do we need to consider? So on my graph here, I'm looking for the greatest amount. So it might be the beginning, it might be the end. It probably isn't this time because I have a giant negative area. So I'm not going to consider this time. I'm going to consider this time because I just had a positive area right before this time. All right, so I need to find that 0. I do second calc 0, so I hit 2. And for that endpoint, good.
Wait, Mr. Sindel, are you sure it's a 0?
That is a 0 right there. If your
It's
graph,
not like 645 in the straight line across.
so remember in my y function, it's y1 minus 645. You do positive rate minus negative rate, and that way you're always looking for a 0.
Okay.
Yeah, so I'm going to come back here. So second trace, you're good. 2, and I'm just going to say left bound 1, right bound 4, giant, oh wait, maybe not 4. Let's go back to 3. And then we'll enter 2 for our guess. If I entered 4, then it would capture both of those zeros. So my 0 here is 2.309. So that is one of the t's that I need. 2.309. Again, I don't need to worry about this 0 because I have a giant negative area before that, and I'm looking for the greatest amount. Can't have greatest if I just had a negative area. And I need my endpoints, 0 and 4. All right, so my start. Start amount in each of these was 0. All right.
If you entered your negative rate as just negative 645 or whatever that number was.
Yeah, I did y1 minus 645 right here in my graphing calculator. All right, so the way that I denote this plus, I don't really need a change here because there's not going to be a change, so my end value is 0. So this one is going to be plus the integral between 0 and 2.309 of my ET, my positive rate, minus my negative rate, minus 645. Oh, come on now. 645. All of that dt. And same thing over here, it's going to be from 0 to 4 of ET, the extraterrestrial, minus 645, all of that times dt. All right, now we need to calculate these. So to do that, I'm going to do, I don't have any initial condition, so I'm going to ignore that. I'm going to do math 9, and it's going to be, this right here is my y2 function, so I'm just going to hit vars right, enter 2. That's my y2 function with respect to x, comma, from 0 to 2.309. And I hit enter.
Can I do y? Oh wait, never mind. You just did that.
All right, so this is going to be, is that right?
Yeah.
Okay, yeah. 1, and I'm rounding all of them to the nearest gallon. So I'm just going to round this one right now. 1,637 gallons. And I'm going to do second enter to get my next function. Second enter. My next function is from 0 to 4, so I'm going to come back here, and I hit 4, and then delete, 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 hit enter. And from 0 to 4, that is going to be 1,401. Perfect. All right, so now to answer the question, let's get rid of the calculator. So to answer the question, when is it the greatest? It's greatest right there. And it's asking what time. So the time is 2.309, and we're in hours. And to justify your answers, you need this table. Perfect. On to part. Yeah, in terms of the scoring, you got 1 point if you had some way of justifying your conclusion with a table, assuming you had your table correct. You get 1 point as 2.309 as a candidate, 1 point if you got 1,637, and 1 point if you have your conclusion as this is the greatest time. All right, on to part C. For part C, this is also extra credit. This is out of 0 points. Come on now. This is out of 0 points because it's, you could have gotten 3 points on this one. All right, so we're basically saying this is how much it costs per gallon that you enter. So we basically need to say enter times the cost, and you'll get the total price. So you'll go from 0 to 4, because those are our bounds again, and you'll now have your price, which is 0.15 minus 0.02t. All of that times your enter function, et, and all of that, well, I don't need brackets, all that dt. And when you calculate that, again, I'm not spending too much time on the extra credit, but to do this, you're going to do math 9, and you're going to do ET was your Y1, so vars right, enter 1. ET times, so in parentheses, 0.15 minus 0.02x. So that is the entire function. Notice that I'm entering the function with my math 9 that I do with respect to x from 0 to 4. And I'll get about 474. Oh, what did I do? What's wrong? Something happened in here. Y1, is my Y1 function correct? Y1 was my ET.
I find that when you do that, Mr. Simba, it always goes wrong for me when you don't enter that function into a Y1 or Y2.
Huh. That's
Like whenever
Yeah,
I
I
do
always have.
so like it somehow goes wrong every time.
really, even if I add like a times or something to get order of operations correct, second insert a times button, I wonder if that'll fix it. There it goes. Okay, so I guess you can't just do parentheses whenever you're doing your math 9. You have to do times in order to get it to come out correct.
So basically, you're just multiplying that new function times your original one.
Wait,
Exactly, yeah.
How do you enter that multiply sign?
The multiply is right here.
But like, how do you enter it without it deleting?
Oh, you do second delete to use your insert function.
Okay.
So, and it's to the nearest dollar. It says it right there, nearest dollar, so $474. And 3 points, so 1 point if you got the answer, 474, 1 point if you have the inside of the integral correct, and 1 point if you got the limits from 0 to 4 correct.
It still says it's wrong.
Mr. Simba, I totally guessed on what to do. It wasn't half bad.
Nice. All right, we need to go on to number 3 because we are still short on time. I want to make sure I get through all of these.
I just guessed. I was like, I'm just gonna. plug this
All right, so,
in.
oops, there we go. Number 3. So,
And I go,
number of gallons is entering a lake. So this is a positive right here.
I didn't enter my keyboard. I just.
And
I just did
we have pollutant stuff. All right, cool. So we need to ask, is the amount of pollutant increasing at time equals 9? So increasing means we're talking about the derivative of the amount of pollutant. So we're looking for P prime. And it gave us P prime. So we need to say, what is p prime of 9? P prime of 9, and we'll find that. P prime of 9. So again, we need to come to our calculator. I'm done with number 2, so I can delete my y1 and y2 functions.
474.
So it does come out to, yeah, so let's go ahead and enter this in our calculators. 1 minus 3 second natural log e to the power of negative 0.2 times the square root, so second square root of t, and sure, end the parentheses there. All right, so we have our rate there. Looks good. So let's go ahead and do p prime 9. So var's right, enter 1 of 9. And when we get that, I get negative 0.646. Is that what you guys are getting to?
Yeah.
So negative 0.646. All right, so is it increasing? Well, this is the derivative. This derivative is negative, so it's decreasing. So the answer is no. And the answer is because p prime of 9 is less than 0. All right, so you got 1 point if you got no and the answer because p prime of 9 is less than 0. Again, the reason we're using p prime of 9 is because we're asking if something is increasing or decreasing. So it's the derivative of, and we're talking about the amount of pollutant. So it's the derivative of pollutant, which is p prime of t. All right, on to part B. For what values of t will the number of gallons be a minimum? Whenever I'm doing minimum or maximum, I'm looking at a table. So t, we need our start and end. Our start was at 0. We don't have an end. And these problems are challenging because you need to make your window big enough to where you can see any critical values. So we need our start plus change, and that will equal our end. Our start for all of these was, there are 50 to begin with, so 50 and any other critical values. So let's look for critical values on our calculator. So our window, we don't know what to set our window to. If we did 0 to 4, it's probably not going to have our answer. I'm going to do my window from 0 to 4D.
I said 4D.
4D. Zoom 0.
I think I did. My window was negative 100 to 100.
That's actually a good idea.
Because I saw the whole graph and I was like, oh, that's where I need to look. And then
So if you notice over here, if you graph from 0 to 4, it would be increasing. You should be thinking, hey, if it's increasing, I wonder if it ever hits 0, because that would be a critical value. So that's kind of one way to think about it. I like Sophia's way. From negative 100 to 100, it should be in there somewhere. It might make the graph too hard to see, but it'll show you all the critical values in there. All right, so I'm looking for a 0 there. So I'm going to do, sorry, not trace, second trace. I'm looking for a 0, 2. I'm going to go between 2 and 40, like this giant interval, and I can just enter 39. Somewhere in between that interval, and it tells me that my 0 is 30.174. Go away, Adobe Flash Player. So 30.174.
How did you do it again? Second trace?
And then you can go from 0 to 40. And then you can enter any number between 0 and 40, like 1, and it will still find that 0. All right, so the start plus change, we don't really care about the change there. It's not going to change. And our end value is going to be 50. Okay, my line needs to be a little bit straighter, Mr. Sindel. There we go. All right, so 50 plus the integral from 0 to 30.174, and it's going to be of p prime of t. I don't have any negative rate to subtract here, so dt. And when I do that, so I can actually do that on my calculator here because I don't have to redo it again. I don't have to go second enter. So I'm going to go second trace the integral for 7, and it's between 0 and 30, come on now, 30.174. And it will shade in this region. It'll tell me a number. Go, calculator, go. You got this. And I need to add 50, so don't forget to do that. This is not adding our initial condition. So I have my answer of negative 14, and then I do plus 50. And I get 35.104. All right, did we need a round in this one? Number of gallons be at the minimum. So here we go. We're just looking for a value of t. So your final answer should be t equals 30.174 days. It'll be at its minimum at that number of days because that looks like it's smaller than 50. And that's the only critical value that we found.
Because we know, okay.
The way that we found that was we set p prime, if you need to write this, you should write this in your notes too, p prime of t, we set that equal to 0 to find our CVs. That's how we found that number.
I remember. No, it's okay.
So now we're going to go on to part C. We're doing good on time. We might be able to slow down a little bit. So,
Wait, can you go back really quick then?
okay, yeah. Do we have questions on number 3 at all? Questions on number 1 or 2 at all? All right, we can go on to...
Okay, you can go.
I didn't wait enough time, but we can always come back to the video and look at this. So part C, is the lake safe? So this is reading from the context. The lake is safe when it is less than 40 gallons. So at its minimum, we know that we have a value of 35.104. So at a minimum, 35.104. It's asking is P of the minimum. So I guess it's really asking is 35.104. Is that less than 40? The answer is yes. So your reason, the best way to do this is because we're taking the antiderivative. So we're saying P of 35, not 35. What was the time here? The time was 30.
30.17.
Thank you, 174. Because the value at this time, which was 35.104, this is a nice way of saying 35.104 in function notation. That is less than 40. So that's a great way of saying our answer. So this one was worth 3 points. 1 if you somehow found 30.174, which can come from your table. This is true in any AP exam. If you're looking for a justification for how you got 35.104, if it came from a previous part in the same problem, you still get the points for it. Yeah, so in the key, it says you needed to somehow calculate 35.104 using start plus end conditions. Well, you did that in part B because you made a table. So you get points for this if you made the table and found this correctly. So you get 1 point if you did that, 1 point if you actually found 35.104 after using your start plus change, and then 1 point if you have your conclusion, this thing, yes, because it's less than 40.
What if I just got yes? But the reason you was wrong.
I don't think you get a point. I think. I would have to ask John because you're basically guessing at that point, right?
No, it's just I got my number wrong.
Oh. So you got your number wrong, but you still said yes?
Like, I still said yes, but like...
I know that I didn't give you points, right?
No.
Because there's one. Were you the person that rounded, and that's the reason that you got it wrong?
Yeah.
So yeah, you don't get points for that. That's like a double
You rounded?
double bad.
I rounded wrong.
So I think what Carly did was
I said 40.
she did
Oh.
time equals 9, and she got 40.1 something, and she's like, oh, if you round it to 40, then it's less than 40. Yeah. Anyway, for part D, this one was extra credit. Another extra credit. Another extra credit. So this is a tangent line approximation. We know this. This is our y minus y1 equals slope times x minus x1. This is a tangent line approximation, and he uses the slope at time equals 0. So how do I find the slope at time equals 0?
It's up at the top.
So the slope at time equals 0 on my calculator, if I come back here to my trace, if I hit 0, the slope is -2. Because this function represents the derivative. If I plug in 0 into the derivative, that is the slope. So -2 goes right here. All right. And it says, what else do we need in here?
The x
Oh yeah, so the x-coordinate. And that comes from our initial coordinate. So at time equals 0, there are 50 gallons. So that's 0, 50. That's the point that I plug in. So my x is 0. This is 50. So my function is y is equal to -2x plus 50. I rearrange a few things. And it's asking, when is this going to be safe? When is this thing going to be less than 40?
So do we plug in 40?
So 40 needs to be put over here, and this thing needs to be less than 40, so -2x plus 50. You're basically setting it equal to it, so we're going to subtract 5.
50?
So I don't know, subtract 50. -10 is less than or equal to -2x, and therefore x is going to be greater than, x needs to be greater than 5. So at time equals 5, it'll be safe, or any time after that.
What's the rule, Mr. Sindel? If you divide by a negative sign, doesn't the sign flip?
It does flip, and then I also flip my variable, so it actually stayed the same. I did a double flip.
Oh.
So if you flip the side of the variable, it changes the sign. If you divide by a negative, it also changes the sign. I did both of those at the same time, so it stayed the same.
Okay.
double negatives.
Oh, that's
So time equals 5 days. Perfect. That was number 3. We're doing good. We have 9 more minutes left of class. By the way, the scoring of this, if you got -2 as your slope, you got 1 point, and if you got time equals 5 days, you got 1 point. So it's possible 2 out of 0.
Yeah. I'm kidding. I said T equals 9.
On to the multiple choice. Here we go. If it's continuous, then if I plug in my suspect point, these should be set equal to each other. So
Oh, God.
5 squared plus
That I did.
5b should be equal to 5 if I'm setting my suspect point or plugging it in and setting it equal to each other. So I'm going to subtract 25 from both sides because that's our 5 squared, and I'm left with 5b is equal to -20. Divide both sides by b is, or divide both sides by 5, I'm going too fast, is -4.
So you just set them equal to and then plug in and then.
Set them equal to, plug in the suspect point. If it was continuous and differentiable, then not only would I do this, but I would also take the derivative of both and then set them equal.
Oh, okay.
All right. So that was number 4, right?
Die.
On to number 5. Come on now, computer, you got this. All right, number 5. What values of x is it decreasing? So decreasing means I'm looking at the derivative. So I need to look at f prime. F prime of x is equal to 15 plus 12x minus 3x squared. And I need to set this thing equal to 0. So when I set this equal to 0, to find my CVs, I can factor out a -3. The reason I'm factoring out a negative is to make this a positive x squared term. This is a review of Algebra 2 and pre-calculus a little bit. So -3, and then what's left on the inside is a positive x squared, a minus 4x, and a minus 5. Some people made the mistake of getting rid of this -3. You need to leave it in factored form. 0 is the reason because you're going to change from its decreasing to increasing with this negative.
Well, I thought I knew what I was doing, but then I didn't know how to get to the answer.
All right, minus 5.
And I factored out
X
the
plus 1. So our critical values are at -1 and 5. And now plug in something. So if I plug in something less than, oh, actually this is probably an easier number. Plug in 0. 0, that's going to be -5, and a positive 1, that's a negative times a positive. So these two makes a negative times a negative, that's going to be a positive. And then because these are both to the power of 1, it's going to flip. That's going to be a negative, that's going to be a negative. It flips over the critical value if it's an odd. If it's an even, then it doesn't flip. All right, so it's asking for decreasing, so it's decreasing less than 1, so I say less than -1, and it's decreasing greater than 5, greater than 5. So which says greater than 5, less than -1? There it is, D.
I just forgot about -3.
Each of these is out of 1 point.
Multiple choice? I was like doing all my work because I was like, I gotta get all the points I can. And I was like, wait, it don't matter.
It don't matter.
It don't matter.
What is going on? I can't move to the next slide. No. It's,
Yeah,
I keep thinking.
there it goes.
I plugged in a 0 instead of a 0.1.
Oh my gosh, my computer's freaking out, guys. What's going on?
Ah!
Ah.
Oh no!
Okay, that was 4. Here we go.
It hurts.
Number 5. And is number 6 the last one?
No.
Okay, so I just can't see what's going on.
I think we have 2 more.
There we go. Okay. So,
I need to go over this.
oh, approximation. Come on, computer. You got this. Oh, it's not writing. There it goes. Approximation. And we're using line tangent. So we're doing y minus y1 is equal to the slope times x minus x1. Minus x1. All right, so we have 0 and 1. So 0 and 1. And we need to find the slope. The slope here is going to be taken from f prime. So they use 0. So if I plug in 0 into f prime, I'm left with 3 times 0, which is 0. Minus 2 is a minus 2 for the slope. And then I just need to plug in 0.1. So I have y minus 1 is equal to -2 times 0.1 minus 0. And 0.1 minus 0 is 0.1. 0.1 times 2 is 0.2, -0.2. And then I need to add 1. That's going to be equal to our y, and that's going to be a positive 0.8 out of 1 points. Number 7. All right, this is going to be the integral of this thing. So what house are we in this one?
E-house.
E-house, tree house, yes. So that means I'm looking at this u. Is du equal to 1?
Yes.
Derivative of this thing is 4x cubed, so it's not equal to 1. That means I'm using taxman. So u tax
Well, I thought I
du.
got, I think I got
All right, so our u is x to the power of 4. Our taxman knocking at the front door is x cubed. Du is 3x cubed. I'm going to treat this as a fraction. This turns into 1 over 3. So I'm going to pay the taxman. Pay the taxman with 1/3, and it's still going to be e to the power of x to the 4. And then when I take the integral, e house stays the same. So when I take the integral, this is going to turn into 1/3 e to the x to the 4. And now I need to plug in 1 to 0. This is really 0 to 1.
Wait, Mr. Snow, shouldn't it be 4x cubed? Because your u is x to the 4.
Sorry, it is 4x cubed. It should be 1/4 for all these. That is a point.
How did you get 1?
Yeah.
Sorry. Yep, it is 4. Good catch.
That's 2, Kale.
Yeah, 2 today. Nice.
Yeah.
So all these should be changed to 4s.
Don't forget.
All right, so from here, I'm going to plug in values. When I plug in 1, I'm going to get e to the power of 1, which is just e, so it's 1/4 e. By the way, the trick here is pulling out the 1/4, and it's just e like this, e minus 1. If I pull out the 1/4, evaluate at 1, and I get e. Evaluate at 0. E to the power of 0 is 1. I get the 1 here, and I subtract because it's 1 minus 0.
So you're done.
And done. Where is that? That's A.
Isn't that I guessed on this one?
And I got it right.
Me too. I think it's because we've done this one so much, and I just couldn't remember it. But I remember
Well,
that
me, I
answer.
thought I was what I was doing. Look.
All right, number 8.
I got it, but I
So we
didn't know
have
what
a
to do.
particle moving with velocity, and it's telling us its position at time equals 1, and it's asking for the position at time equals 2. All right, so we need to take the integral. It's start plus change equals n. So at time, start plus change
Did not do that.
equals end. All right, at time equals 2, that's what we need to find. So it starts at position 7, and you need to do the change. It starts at 1 for the time, though, from 1 to 2. It's not from 0 to 2. So change of vt. I'm just going to write vt because I'm lazy here. dt. And I need to find what that is equal to. Don't forget your start position. It's going to be 7 plus whatever this integral is. Let's deal with this integral now. Integral from 1 to 2 of 4 minus 6t squared, all of that dt.
Oh, I know what it is.
That is going to equal, well, you basically take the integral, the antiderivative, and distribute. Integral of 4 is 4t. Integral of negative 6t squared is negative 2 negative 2t cubed. And now I evaluate that from 1 to 2. So when I do that, plugging in 2, that's going to be 8. And then plugging in 2 here, 2 cubed is 8 times 2 is negative 16. And I'm going to subtract when I plug in 1. When I plug in 1, it's 4 times 1, which is 4. And when I plug in 1, 1 cubed is 1, times 2 is 2, minus 2. So this is going to be negative 8 minus 2. Negative 8 minus 2 is a negative 10. I think there's one person that got negative 10 right, but forgot the initial condition. That is going to be a negative 3. Correct answer is C. All right, that concludes Unit 8 pretest. Are there any questions? Questions on the pretest?
No.
Why am I so
All right.
stupid?